Hello, my name is Michael West, and on behalf of the CMMI Institute, I want to welcome you to this session of the 2018 Capability Challenge. Let me introduce myself. I am Michael West. I am a consultant and author of 2 books on process and performance improvement. I had the honor of being the 2017 Capability Conference Chair and one of the challenge judges. And I also have the honor to be the 2018 Capability Counts Program Executive. The Capability Challenge competition showcases thought leaders from around the world who are improving their business performance by building organizational capability. This year, we have 9 fantastic Capability Challenge stories, and in a few slides, I'll be introducing you to tonight's challenger. I want to point out, I want to give recognition to Prem Ranganath. He was the 2017 Capability Challenge winner, and his story was very compelling, and it was about integrating cultural change with technology change. So congratulations again to Prem. I also want to tell you some of the major differences between how we ran the Capability Challenge in 2017 versus this year, 2018. In 2017, we had several rounds of live webinars in which 3 or 4 contestants competed in the same webinar. And then following each webinar, the audience would vote on their preferred presenter, who they thought was the best story and the best presenter. In 2018, we're changing it up a little bit, and the presentations are all recorded without a live audience. Once these videos are posted on the CMMI Institute's website around the first week of February, the community will have a period of time to view them and vote for their favorite Capability Challenge story. How the voting works. So the 3 Capability Challenge finalists, that's 3 presenters who will be chosen via a combination of audience vote and the judges vote. And these 3 finalists will compete against each other in the final round, which will be done live in the Capability Counts Conference in May in Reston, Virginia. And I've got some more information about the conference at the end of this presentation. Let me introduce you to this year's Capability Challenge judges. Becky Fitzgerald is one of our judges. She is also the Capability Counts Conference Chair this year. She has extensive experience in healthcare, corporate consulting, academic environments. Becky's a certified CMMI lead appraiser and enterprise data management expert with expertise in laboratory regulations, in rules, code and data set management and transaction requirements, ambulatory, hospital, laboratory, and imaging workflows, and medical device development. Our second judge, Michael Callahan, was the 2016 winner of the Capability Challenge. He is the president of Aegis.net Inc., and he takes a hands-on approach to his company's process improvement initiatives, and which was central to them winning in 2016. Michael brings a wealth of experience and knowledge and expertise, and we're very happy to have him as one of our judges this year. And our third judge is Prem Ranganath, a 2017 Capability Challenge winner. He is currently Vice President of Quality at Trilliant Networks. In this role, he's responsible for developing and implementing a comprehensive quality strategy for product engineering covering people, processes, tools, and an enabling culture. Now, let me tell you a little bit more about how the judges select their favorite presenter in a challenge. The panel of Capability Challenge judges will use criteria to judge the challenge presentation. The criteria are originality and innovativeness, credibility, value to the conference attendees, presenters' qualities and presentation skills, and measured success from CMMI adoption. The judges have been provided detailed definitions for these judging criteria, and none of the 3 capability challenge judges have a relationship, personal or professional, with any of the 2018 challenge competitors. Now I want to introduce you to this session's presenters. I would like to present to you Mr. Vladimir Savin. He is a doctor in computer science, power engineering with data science experience. He previously worked as a process manager in ScienceSoft, a quality director in Semitech, an expert in Galactica Corporation, a project manager in Client Server Programs Ltd., and a senior research officer in Belarus Scientific Research Heat Engineering Institute. All companies are in Minsk, Belarus. His skills include data science, operations research, deep learning, machine learning, Python, R programming, Six Sigma, Lean Six Sigma, KNIME, software engineering, technical writing. During the 2010 through 2017, he has elaborated hundreds of processes. And with that, I want to turn it over to Mr. Savin. And sir, you now have the microphone, so please tell us your capability challenge story.
Dear colleagues, let me start. My name is Vladimir Savin. I am PhD in computer science, and my main responsibilities are related with information security, quality, and CMMI high maturity implementing. To support such directions, it is extremely necessary to know and implement data science, machine learning, operations research, and manifold statistical methods. My proposal is deep learning for software engineering, in 2 cases, predicting delivered story points and story points per man-hours using deep learning. EPAM can help your business transform. Our multidisciplinary teams combine business expertise with design thinking, world-class engineering, modern operations practices, and knowledge of leading tools and frameworks to optimize performance. EPAM has been rated at CMMI for development maturity level 5, 2014-2017. Deep learning methods truly represent the 3rd generation of neural networks. The company's goal to maintain continuous improvements in our processes and improve accuracy in our predictions. EPAM has piloted artificial neural networks and deep learning methodologies in a number of projects, as these can deal with non-linearity more effectively than traditional regression analysis if the data have nonlinear dependencies. They are able to predict more effectively and accurately than our conventional methods, and they allow the company to plan the resources more effectively. For software engineering, we implemented artificial neural networks and deep learning as predicting tools to indicate team performance. Results were represented and published at corporate conferences at 2014 and 2016. Adopting artificial neural networks and deep learning represent our approach for the continuous improvement results in increasing stability and capability in our processes. Our improved methodologies and tools can serve as best practices to a wider community committed to CMMI principles. The main metric used in selected projects was delivered story points per sprint. The achieved performance improvement is manifested in increasing their mean value while decreasing their standard deviation. The innovative improvement we achieved last appraisal in March 2017, artificial neural networks resulted 22% decrease of standard deviation of actual velocity compared to the traditional statistical method like multiple regression analysis. For selected projects, the coefficient of variation of predicting delivered story points decreased from 40% to 33%. Artificial neural networks and deep learning methodologies support the company's long-term corporate business goals. Thanks to my approaches, any team in the company is able to implement ready-made deep learning solutions with free software. Deep learning architecture. This diagram shows a deep learning for numeric prediction with 3 independent numeric variables. The net was configured to have 2 neurons in the first hidden layer and 3 neurons in the second hidden layer. The behavior of the net is determined by its topology, the number of hidden layers and the number of nodes on those layers. The weights of connections, a parameter assigned to each connection, and bias terms, a parameter assigned to each neuron. Activation transfer function used to convert the inputs of each neuron into its output. Deep learning and artificial neural networks developed its 4 steps. Data preparation. The data we use is defined in datasets. Training. With training, a neural network is generated from a dataset comprised of cases with known output values. Testing. With testing, a trained neural network is tested to see how well it does at predicting known output values. Prediction. A trained neural network is used to predict unknown output values. Deep learning algorithms. We are using multi-layer feed-forward networks approximating complex relationships between independent variables and the independent variable with backpropagation. The basic backpropagation algorithm adjust the weights in the steepest descent direction, negative of the gradient. This is the direction in which the performance function is decreasing most rapidly. To reduce the risk of finding the local rather than global minimum, we combine deterministic with stochastic optimization methods. Specifically, the stochastic simulated annealing method is used along with the conjugate gradient descent method. Optimizing delivery story points. There are, on the right, there are 2 hidden layers. Each has 3 nodes. Above 3 million epochs were done to achieve global extremum. The training progress window reports on the status of network training as it runs. The graphs show how deep learning is improving the network and reducing the reported error. The training progress window reports the prediction error on the training data. On the left, relative independent variable impacts on story points per man-hour predicting is shown. The same we did for delivered story points predicting. On the right, overlay accuracy % story points per man-hour in MRA versus deep learning is shown. MRA is in red, deep learning is in blue. Deep learning accuracy is much better. To demonstrate accuracy of optimizations and provide comparison of performance using MRA and deep learning, we use Monte Carlo simulation technology and the TRISC tool. For example, in Monte Carlo histogram below, x-axis overlay accuracy % story point per man-hour versus deep learning. Y-axis is frequency of MRA versus deep learning. Confidence interval 5% to 95% is a particular kind of interval estimate of population parameter and is used to indicate the reliability of an estimate. Please see below confidence limits are the lower and upper values of a confidence interval. A confidence interval gives an estimated range of values which is likely to include an unknown population parameter. Thanks. Please let me know your questions.
Well, thank you very much, Vladimir. That was a wonderful presentation. I do have a couple of questions, and I'm going to back up to one of your slides to ask my question. On the left-hand side, in this deep learning architecture diagram, are these layers of the second hidden layer and the first hidden layer, are those conditions, are they defined somewhere? Would we find definitions for what that means?
We use deep learning methods which use methodology to automatically represent any data set in the form of neural networks. And very big progress in this methodology compared with artificial neural networks. Deep learning is third generation of artificial neural networks, and it construct hidden layers. Hidden layers allow us to do additional approximation of data, include take into account any non-linearities, and allow us to do many additional tasks. IT giant like Google, Oracle, Microsoft used this methodology to natural language processing, image recognition, and many other tasks. It's future of mankind because we can use this technique for robotic program application in many productions, and a very good perspective for software engineering, because it's only example we can demonstrate on predicting delivery story points, but we can use for predict quality, defects, and other effort and other problem we have in software engineering.
All right, thank you. Okay, and that brings me to my closing remarks about the challenge and the Capability Counts conference. Now remember, listeners, the 3 finalists will be selected to present their stories at the Capability Counts 2018 conference. And then I just want to put a plug in for the conference itself. It's May 1st and 2nd in Reston, Virginia, at the Hyatt Regency. This is without question the world's premier conference in process and performance improvement and capability improvement. And so I encourage you to go out to the CMMI Institute website, look at the program, and then somehow make it to Reston, Virginia, because you will definitely get your registration fee back in all of the practical and valuable improvements that you could take home with you and implement in your own home organizations. So with that, I conclude tonight's webinar. Thank you and good night.